All right, in this video, I have 4 more skills that will help you out in Gen Chem. These are some must-knows. Lewis structures. Actually, I find these to be enjoyable, so bear with me on this. First step is valence electrons, so count them up. Valence electrons for carbon 4, and then we have 4 hydrogens, and each one has 1. So first of all, valence electrons equals 8 total. You need to know this so that you can draw these structures. Now, guess the central atom. Hey, let's go with carbon, surrounded by 8 hydrogens. Okay, and then we're going to position those electrons around. I have 8. Well, I just so happen to need 2 to bond every hydrogen to the carbon. Now, how do we know when we're done? Everybody has 8, except for hydrogen. So hydrogen just sees 2. Every hydrogen sees those 2 as their own, and then the carbon sees 2, 4, 6, 8. So that is a valid Lewis structure. Now let's do nitrogen. So as far as valence electrons, each nitrogen has 5. And so I have a grand total of 10 valence electrons. Well, central atom doesn't really apply here because we just have 2 nitrogens. Now I have to bond these together with 10 valence electrons. So let's just start 2, 4, 6, 8, 10. And I get to this point and I say, well, they don't all have 8. So I'm going to need to do some extra bonding here, extra sharing. So let's grab 2 from one of the nitrogens and kick them in here. The nitrogen on the right has 8, but the one on the left still has 6. So let's let this guy on the right share 2 more. There we go. We've got 8 on this nitrogen, and then we have 8 on this one. So that's a little refresher on Lewis structures. Hey, it's trial and error. Don't worry if you don't get it right the first time. Just keep trying. All right, the next one is writing and balancing equations. Okay, I know this sounds very basic, but identify your reactants and products first. So I see that aluminum and oxygen are the reactants because they're going to produce, and then my product is aluminum oxide. So once you get that established, let's try to write these formulas. Well, aluminum, that's easy, just solid aluminum. And then oxygen gas, remember, is a diatomic, which means it's O2, 2 oxygens bonded together. And then our product is aluminum oxide. Now, don't just slap the aluminum with 2 oxygens on it like this. This is not the formula for aluminum oxide. So what is the formula? Well, this is an ionic compound, and it's made up of the aluminum ion and the oxide ion, which is O2-. So how do those 2 ions combine such that the total charge is 0? Well, we're going to need 2 aluminums to give me +6 over here, and then 3 oxygens will give me -6. Okay, so 2 of these plus 3 of these. Okay, and then we're going to write it like this. So our formula is Al2O3, and that happens to be a solid. Now we're going to go back and balance. Okay, so to get the oxygens to match up, I'm going to need to, notice I have a 2 and a 3 here. Notice I'm going to have to multiply to get 6 on the left and then get 6 on the right. Once that's done, it's easy. I just need 4 aluminums on the left. So writing and balancing, the more you do it, the better you'll get at it. All right, the next skill is equilibrium constant expressions, and that is the good old, you might see it as a KEQ, you might see it as a KC. It's capital K, and this expression, I'm going to do a KC here. We're going to put our products on the top, and we're going to use the brackets to indicate molarity. Okay, so the only product I have is ammonia, and then we're going to raise that molarity concentration to the exponent. So because there's a 2 there, I'm going to square that concentration. Now, we only include the terms that are solids, only include gas and aqueous. Okay, so if it's a solid or a liquid, don't include it. Well, everything here is a gas, so they're all going into the expression. Products on the top, reactants on the bottom. So there's nitrogen, the coefficient is a 1, so it's raised to the first power. And then I have my hydrogen concentration and molarity raised to the third power. So that is concentration, that Kc right there. Concentration brackets mean molarity. There is also an expression using partial pressures, which would be a Kp. And Kp would involve the partial pressure raised to those exponents, just like these concentrations. All right, and that's for gases, of course. And then the next one would be acids in water. I recommend memorizing the strong acids and the strong bases. And if you know those, then everything else is going to be weak. So look that list up, memorize that. Now, what do strong acids do in water? They completely dissociate. Memorize that fact. They completely ionize. So every single one of them will come apart and form ions. So if we had 0.1 molar hydrochloric acid, guess what the concentration of H plus would be? 0.1 molar, and we'd have 0.1 molar of that. None of it would be staying together. So strong means completely dissociate. Now, in contrast, weak acids, this one happens to be nitrous acid. Now, don't confuse that with nitric. Nitric would have 3 oxygens on there. They look very similar, so be careful. So we have equilibrium in this case, and I'm going to emphasize equilibrium. They only partially dissociate, so you're going to write an expression like this. So the hydrogen ion, only some of them come apart, and some of them would stay together. And so if we had a 0.1 molar solution of that, we would not have 0.1 molar of H+. We would have only a small amount. And we could write the equilibrium constant expression for this, and that would be what we call the acid dissociation constant. And those are known values. In fact, the Ka for this acid happens to be 4.5 times 10 to the minus 4, which as far as a Ka is a pretty good sized number. So the bigger the number, the more it dissociates. If you have a really tiny exponent right there, like 10 to the minus 20th or something, that would mean very few of those H pluses come off of that acid. So very similar situation for strong bases. Strong bases completely dissociate, and weak bases will only partially dissociate. So I hope that helps you understand that. You need to put in your bag of tricks that you can apply to all types of problems. I hope that helps you can do chemistry.